a diagram of your address binding with the following steps. I can explain you in detail. With the source code compiled to the object code, and the object code is also linked to the producing an executable, and the executable loaded into the memory, and your MMM will always maps to the logical address to the physical address during your execution. So this diagram will explain you the transition from logical to a physical representation. So next we move on to the next slide of a logical versus your physical address space. The logical address, we all know that the logical address is all about a virtual address. So the logical address where your address will always be generated by your CPU. That is what the logical address is all about. Whereas physical address, the physical address enables your actual location in your memory. The virtual memory is where the mapping a logical address to the physical one using your memory management unit. Could you please state me what are the basic advantages of the things? If not, can I also state the basic advantage like security, abstractions and multitasking support. The security is all about the process cannot access your other's data, and abstraction, the program can use more memory than your physical available, and we have a multitasking support to be carried out. So we will see in detail about what is memory management unit in this slide. So the hardware device that translates your logical to the physical address using a relocation register and the base value keeps your address translation transparent to the user and the program. Hence it enables the execution of time binding and your dynamic reallocation. So the next is about the dynamic reallocation. It allows a program to be moved during your execution without any changes. Hence we have a reallocation of your register adds to the offset to the logical address. Helps you to utilize your memory efficiently by shifting a program in a RAM, random access memory. We all know about it. So crucial for the system with the multitasking and your virtual memory is all about this dynamic reallocation. Next we can move on to the next concept of dynamic linking. The dynamic linking will be, we are all aware of the libraries which are linked at your compile time when needed at your runtime. So share the libraries can be used by the multiple process, shares memory and the disk spaces, helps in your modular development and your easy updates. So next we move on to the dynamic loading. Routines are loaded only when required, hence we reduce your initial load time and the memory footprints required to the programmer to design the logic for loading your modules, or the OS does not do this false when the program driven is carried out. Next is about the dynamic linking and the loading. When we combine the dynamic linking and loading, the code and the libraries are loaded and the linked during your execution. Reduce your RAM usage and enables a faster startup. Useful in a larger software system with many modules. The next is all about overlays. The overlays is the purpose of overlaying is just executing the program larger than the physical memory by loading into unnecessary parts. How it works? The question may arise among you. It divides your program into overlaying, that is a unit, logical unit, or we can state that as a modules. Only one overlaying as a set, we consider that as a set which is loaded into the memory at a time, and the programmer manually manages which overlay loads even. Very common example we can describe is in a sorting program. The phase 1 is just loads a sort routine, and the phase 2 unload a sort, load merge your routines. The basic as a overlaying, it reduces a memory usage, non-OS level supports, requires a careful planning by the developers. Still, it is also used in embedded system with a tight memory constraint. The next is all about the swapping. The swapping, the purpose of the swapping is just manage the limited RAM by temporarily moving the process to the disk. And the working style of this is where it is an inactive or the idle process or swapped out to reserve an area on the disk, or we can call it as a swap space. When needed again, the process was swapped back into the RAM. The main advantage of this is just increasing your CPU utilization and allows more processors to be more active without overloading a RAM. The basic challenges in this is all about the disk input and output is very slow. Frequently swapping may lead to crashing, and it also requires your OS supports and efficiently scheduling to avoid the performance drop. And an operating system hence